Okay, for question 2, the question asks you to show the initiation step, propagation step, and one possible termination step that are involved in the production of 2-bromopropane with the presence of UV light. For the question like this, first you need to write the general equation. So it states that your product is 2-bromobutane, and you are using bromine in inert solvent. So when it states that initiation step, propagation step, you will go directly to the radical substitution halogenation. So your starting material can be, so here is your product actually, butane 1 2 3 4 1 2 3 4. So here is UV light, and at BR should be here, there is one hydrogen here, is substitute with BR plus BR2. Basically this is the general equation for this reaction. However, the question asks you to give initiation step. So you can proceed first with initiation step. So always remember, at initiation step, it involves bromine radical, because initiation step is a very crucial step because you want to create a radical by using UV light. UV light will break the bromine molecule homolytically. So should be here, one electron goes here and one electron goes here. So here you need to put UV light, and the answer should be BR dot. BR dot is representing a radical, so another BR dot. And then you need to proceed with propagation step. So at propagation step, it involves 2 steps. Step number 1 is formation of alkyl radical. So in this step 1, so you have butane, and then this butane react with Br that you already produced at step initiation. So you want to attach bromine here, right? Your product should be, you substitute hydrogen at this carbon. Like this, if I show you the hydrogen. So bond will break here. One electron will goes here and one electron will goes here, and this electron will combine with this radical to produce, when the hydrogen lost from this carbon, so here it will be radical plus this hydrogen is combined with bromine, so to form hydrogen bromide. This is step number 2, and then you proceed step number 1, and then you proceed with step number 2. Step number 2 happen when you take this radical, butane radical, and then you react back with another bromine molecule that has not yet be converted to radical Erical. So because let's say you have a container, you need to imagine there are a lot of radical and also a lot of bromine molecule. So this Br dot is representing the radical that already converted from bromine molecule to radical. And for the bromine Br2, there is some bromine molecule that still exists in the container. So this bromine molecule will react with butane radical. So what happened here? So bond will break here. One electron goes here, one electron goes here, and then this will combine with bromine, so it will produce Br plus Br dot. So again you will reproduce bromine radical. Then after that we proceed with termination step. So what do we have at termination step? So normally termination step involve 3 steps. The first step is related with bromine. Bromine no bromine radical react with bromine radical itself to produce back bromine molecule. And then for step 2, bromine radical react with butane radical to produce 2-bromobutane. So this Br combined with this radical, recombine with radical. Here you need to put Br. And for step 3, the butane radical react with butane radical itself to produce an alkane. Is that step number 3? Normally you will produce another type of alkane. Normally the product is much more longer or much more carbon compared to the first product. First starting material. So should be this radical combined with this radical. So you imagine here. So here is the place when a radical form. So you need to put bond at the place when the radical form. So it will be like this. Because here initially at the beginning of the reaction, here is the place when the radical exists, and also here is the place when the radical exists. So when these two molecule, when these two compound combine together, you need to put bond here. Okay. And then what is the name for this mechanism? So you can put radical substitution. radical substitution, or you can put radical halogen substitution, or you can put halogenation. All answers are acceptable. Okay.